This is question 2 in the third set of discussion questions. The first three parts of this question are asking, what is the MAD of class 1, what is the MAD of class 2, and what is the MAD of class 3? The MAD is the mean absolute deviation of a data set. So parts A, B, and C are just asking you to calculate the MAD of a certain data set. To answer A, B, and C, we have to go down to this picture right here. This picture is showing three different classes. Each class has 12 students, and each class just took an exam. In class 1, the 12 students all got 75s. In class 2, there's a little bit more spread. The scores go from 73 to 77. In class 3, there's even more spread or dispersion. The scores go from 71 all the way up to 79. Each class has a mean of 75. So all three classes have the same mean, or the same average. If you add up these 12 scores and divide by 12, you get 70. Sorry, if you add these 12 scores and divide by 12, you get a mean of 75. The same thing would happen here and here. In each of these diagrams, I labeled the distance from each exam score to the mean. So this 0 right here is just showing that this exam score of 75 is 0 from the mean. It's equal to the mean. Just like how this 0 is also showing that this exam score is 0 from the mean. In class 2, this 2 is showing that this exam score is 2 from the mean of 75. It's 2 below it. This 1 right here is showing that this score of 74 is 1 from the mean of 75. So all of these numbers that I labeled are just distances. They're just the distance from the score to the mean. To get the MAD of a data set, you have to calculate the mean or the average of all of the distances. So to get the MAD of class 1, you would add the 12 zeros and divide the total by 12. And you would get the mean of all of these zeros, and that would be the MAD. You would add, that I labeled here, plus 1, plus 2, and divide the total by 12. And you would get the mean of all of the numbers that are labeled in here. In class, that would be the MAD. To get the MAD of class 3, you add these 12 numbers and divide by 12. Plus 2 plus 2, plus 0 plus 0 plus 0 plus 0, plus 2 plus 2 plus 2, plus 3 divided by 12. That would be the MAD of class 3. So in each of these classes, the MAD is just the mean or the average of all of the numbers that I labeled next to the x's. Part D says, what is the MAD? And then part E says, what is the reason why the third data set has the largest MAD? The MAD goes up when the data is more spread out. And when the data gets more and more spread out over a wider range, the MAD gets larger. We can see that class 1 has very little spread or very little dispersion because it has no dispersion at all, actually. All the scores are the same number. We can also see that class 3 has quite a bit more spread or dispersion because the scores go as low as 71 and as high as 79. So basically, when the scores are spread out further away from the mean in both directions, the MAD gets larger. Question part F says, if someone told you that a certain class took an exam and the MAD of the class was 0, what would that tell you about the scores of the students? Right here, well, try to calculate the MAD of class 1. Add these 12 zeros and divide the total by 12 and see what you get. See what the MAD of class 1 comes out to. Once you get the MAD of class 1, I think you'll see what this question is getting at. If the MAD comes out to 0, that means that all of the score that there's no spread. All of the scores are the same number, and there's no deviation from the mean at all. Part G says, imagine that two classes, well, first I was going to say, also, the MAD is measuring the dispersion or spread of a data set. So if the MAD is 0, that means that there's 0 spread or 0 dispersion. All scores are the same number. So part G, imagine that two classes at JFK both have a mean of 75. They have the same average. However, the first class has a smaller MAD and the second class has a larger MAD. And it's asking you what's different between the exam scores of the two classes. Well, I was mentioning earlier that the MAD measures the amount of spread or dispersion in a data set. So if the MAD comes out to a larger number, that means that the scores are more spread out, basically. And that's all for this question.